So once we've added and subtracted, once we multiplied and divided, now we're going to add and subtract. So adding and subtracting, again, rational expressions are just fractions. How do we add and subtract fractions? How do we add 1/2 plus 1/3, right? How do we add it? Well, don't we have to get something first? Right, a common denominator. So that's our first step, is find the LCD. And then don't we know here that the LCD would be 6, right? Between 2 and 3. So what do we do with that? Right, we change the fractions to the LCD. And that's going back to unreducing the fractions, really. So 1/2 is reduced, right? Change the fractions to the LCD. 1/2 is already reduced. I'm going to unreduce it to 3/6. 1/3 is already reduced. I'm going to unreduce it to 2/6. Then I add or subtract the numerators, right? Whatever those are. Add or subtract the numerators. Oops. And I'm going to keep the denominator. So this is 5/6. In other words, it's not 5/12. So I add or subtract the numerators, keep the denominator. Keep the denominator. And then at the end, if I can reduce the fraction, I do. 5/6 seems like it's good to go. How about 5/7 minus 3/14? What's the LCD? Right, 14. So if I unreduce this, it would be 10/14 minus 3/14 would be 7/14. And of course, I reduce my final answer to 1/2. Perfect. What's the LCD in number 3? Right, 12. So, and by unreducing, what you're really doing is multiplying the top and bottom by whatever that fraction needs to become the LCD. So this last fraction needs a 3 plus 15 over 12. So altogether here I have 40 over 12, which again you would reduce to 10/3. So I know that you know how to add and subtract fractions. So now we're going to add and subtract rational expressions. So now we've got letters and numbers. Number 4 is actually a little bit of a unique one. The LCD in number 4 is C plus 1. And this first fraction, it needs to be multiplied top and bottom by a C plus 1. And if I distribute, I get C squared plus C plus 2 over C plus 1. And that actually does not reduce. I'm just done. What's my LCD in number 2? Number 5, actually. Right, 6xy. Sometimes I like to write it out on the side. LCD 6xy. So I got 2y, 2y, 3x, 3x. And so what am I going to have? Negative 14xy squared over 6xy plus 12xy squared over 6xy. Now you have to, fight the urge, I guess, to reduce those fractions. You just unreduced those fractions, just like you did up above. These are like terms here in the numerator. They add up to negative 2xy squared over 6xy, and then I can reduce it. So I'm going to end up with negative y over 3. All right, so number 6 is kind of our first kind of normal, I think more normal one that we're going to see, where the LCD here is x minus 1 times x minus 3. So in the first fraction, I get 2x minus 1. And then here, this is going to be a negative 1 that gets distributed, so it's negative x plus 3, all over x minus 1, x minus 3. If I combine my like terms in the numerator, what do I get? X plus 2, x minus 1, x minus 3. You do not have to FOIL that in the denominator. It's not wrong if you do. I tend to just leave it. Now in number 7, it's smart to factor that first 3 times the quantity x plus 2. It'll make it much easier to see that the LCD is 3 times the quantity x plus 2. This just needs a 3, this just needs a 3. So this is going to become 9, right, plus 4x plus 5 over 3 times x plus 2, or 4x plus 14 over 3 times x plus 2. Perfect. Number 8, what's the LCD there? I'm thinking it's 15 ABC. right? So this fraction needs a 5a, this fraction needs a 3b. So I'm going to have 20a squared minus 45b squared all over 15abc, which I can simplify. I can pull a 5 out of the numerator. So 5 times 4a squared minus 9b squared, which that does factor again, but it's not going to allow anything to cancel. So like once I cancel this with the 3, that's good for the answer. If you wanted to factor the numerator, you could. You didn't have to. Last one. Now this, of course, looks the most intense, but I'm going to reduce each fraction first. So I don't always do this, but I notice that there's some canceling waiting to be had here. So in the first fraction, I can cancel the x plus 1's, and I have 3 over x plus 1. And in the second fraction, I can cancel the x minus 1's, and I'm left with 1 over x minus 1, or 1 over x plus 1, rather. So I have a common denominator already, and I can just add the numerators, 4 over x plus 1. Every problem's a little bit different, right? But it's still going to follow the same basic format of finding the least common denominator, changing to the least common denominator, and then adding or subtracting.